Hello, aspiring homeowners. This is a presentation on the Calgary real estate prepared for the BTMA 431 class. Our motivation behind this project is that we are all currently university students who will be graduating soon, and we all hope to eventually own our own property in Calgary. We also wanted to be informed on which variables will impact the price of different properties so that we can make an informative decision when buying a house. Before we get into the analysis, let's briefly go over some of the factors that may influence property value. Some of these factors may include population of the city, the current labor market, and inflation rates, as well as the size and location of the house.
So part of our approach to gathering our data included dividing the city into different quadrants. We divided the city into 8 different quadrants: the north, northwest, northeast, west, city center, east, south, and southeast. Within each quadrant are different communities from which we gathered our data. So we gathered our data from MLS listings in Calgary. Essentially what we did was we created a set of functions to scrape data for each of the quadrants in the city. We looped through each page of listings within the quadrants and collected data on the house price, address, neighborhood, number of bathrooms, number of bedrooms, and square footage for each listing in that quadrant. Then for each of the 7 remaining quadrants, we repeated the scraping process. Once we had data for all of the quadrants in the city, we combined all of this data into one large pool of data. We then removed any extraneous data that needed to be cleaned, and we were left with all the cleaned listing information, which we later used in our analysis.
So after we scraped the data, we came up with the following independent variables. So the number of bedrooms, the number of bathrooms, the square footage of the house, and what quadrant the house was found in. So whether it's the northeast, southeast, southwest, etc. And our dependent value was the house value, which is the price of the house. So we thought it would be interesting to look into the most expensive house on the market, and we found that it was $8.95 million, and it's located in Southwest in the Aspen Woods community. It has 5 bedrooms, 8 bathrooms. It's about 5,000 square feet and is a total of 1.04 acres. So our original question was, which housing factors contribute the most to listing price? So we looked at, again, the square footage, the number of bedrooms, number of bathrooms, and where the house is located in Calgary.
Here we have a visual of a basic plot created on R. As you can see, it shows the different proportions of the 8,200 homes listed on calgarylistings.com. As you can see, the center and west regions have the most offerings. Here we have a basic comparison of 2 bar charts that compare square foot and price. This is to help visualize our variables. As you can see, the downtown prices are quite inflated compared to the square feet you are getting. Here we have our correlation plots that show a very high correlation between bedrooms and bathrooms with square feet. Therefore, in our final regression, we decided to remove bedrooms and bathrooms to reduce multicollinearity factors.
So before we continued our regression model, we needed to do a regression diagnostics. In order to do a regression diagnostics, we needed to look at 4 factors. One was if the relationships are linear or not. Other was multivariate normality, in order to ensure that the variables are normally distributed. No or little multicollinearity. As you saw on the slide before, with the correlation plot, we did take out variables that were, the independent variables that were correlated to each other. And of course, we also had homoscedasticity. So we need to make sure that our error terms are not heteroscedastic. And now this is our regression model here. So our regression model takes the log of listing price equal to beta of 0 plus log of square feet, as well as our dummy variables, which are categorical. And now keep in mind, as we move forward, center is our reference point, aka the variable that that basically occurs when all the other variables, which are in the dummy variable, are 0. This is our regression plot for one of our diagnostics. As you can see here, the variables are fairly normally distributed in terms of their residuals. Now, this is our regression output. And now, as you can see with the regression output, there is a strong correlation with square feet in terms of predicting listing price with square feet. And since a city center here is our reference point, which you saw before was the most expensive quadrant in terms of prices in Calgary, it makes sense that the sector east, sector north are all negative here. And our multiple R squared is 71.72%. Now, and I guess to end off the this report here, I just wanted to show a Power BI visual in order for us to have a look at what each quadrant has in terms of prices. So, for example, if we were to look into just Applewood Park, you could see all the MLS listings within Applewood Park here. Now, the circle here represents the size of the circle here represents how expensive the property is, and the square feet is represented by the colors. Now, moving on to our second Power BI visual is our listing price and square feet by location visual. So this actually breaks down all the city quadrants into areas where you can see. And if, for example, if you were to select the Southwest here as an example, you would see all the MLS listings within the Southwest, and you can also select multiple ones as well if you would like. And if we were to zoom in a little bit, we could actually see all the listings that are in the Southwest of Calgary. That concludes our presentation. Thank you for listening.